So now we're going to use synthetic division to do everything to a function. You can see all the list A through E. We'll go through one at a time. We're given this function, this fourth degree polynomial, and we're given two factors. So first, it says verify the indicated factors of f of x. So we want to verify that they are factors. We want to verify that they divide into this function evenly, that means. So we're going to run it through synthetic division and show that we get a remainder of 0 for each. So here we go. So I'm doing A right now. We'll start out with x equals 5. If x minus 5. If x minus 5 is a factor, that means x equals 5 is a 0. So if you run through synthetic division with 5, we are going to get 0. If we don't, then we have to check our mistakes. Here we go. Multiply by 5, add, multiply, add, multiply, add, multiply, add. Perfect. Now we're going to do the same thing with x plus 4 or use negative 4. But here's the deal with this. Don't start all over again. This is our remaining polynomial, our quotient, really, and negative 4 would be a factor of that as well. So we're going to just keep going, kind of stack the synthetic divisions, because that's going to break down our polynomial into a lower degree that we can handle. So when I run negative 4 through it still should be a factor, and I still should get 0. So let's do it. 1 times a negative 4 is negative 4, negative 3. Negative 3 times 4 is 12. Add, multiply, perfect. Now, that means what's left over is x squared minus 3x plus 2. This is a quadratic, an easy polynomial to deal with. So when we did the synthetic division first, this fourth degree down here turned into a third degree. And when we did synthetic division again, the third degree reduced it to a second degree. So every time you do synthetic division, you're reducing a degree. So we verified the factors. That's where we are. We need to now find the remaining factors. That's easy, because we have this simple polynomial left. Just factor it. Factors of 2 that add up to negative 3 are negative 2 and negative 1. So now we have found the other factors. So now we need to use our results to write the complete factorization of f. So let's do that right here. We have x minus 5 and x plus 4. That's what we started with. So I'm looking at C here. And then from our synthetic division, we found two other factors, x minus 2, x minus 1. And now we've just answered part C. We have the complete factorization of f right here. And now D, that's easy. If you have the complete factorization, the zeros are very, very simple. So the zeros are what would make this whole function 0, and since it's factored, you just set each factor equal to 0. So we have x equals 5, x equals negative 4, x equals 2, and x equals 1. So that was simple. Confirm your results by using a graphing calculator. We're going to kind of change that. Let's just graph it. Let's use what we've learned so far to graph this polynomial. So it's an even degree polynomial. The leading coefficient is positive. So the leading coefficient test says it starts up, ends up. We found 4 zeros, and all of them have multiplicities of 1. So we're at 5, -4, 2, and 1. Starts up. These multiplicities are odd, so it's going to go through. Y-intercept is -40. So this is going to go all the way down to -40. Has to go up through this one, down through this one, and then back up through this one. So that's what the graph looks like. We're done. I'm gonna do E now like they wanted me to. I'm gonna show it on the graphing calculator just to make sure. So here we go. X to the fourth minus 4x cubed minus 15x squared plus 58x and minus 40. And then the graph should look sort of familiar, sort of like what I have. There it is. Oops, I lost it. Oh, there it is. So you can see it does start up, goes through 5, goes all the way down to -40 down here, up through 1, down through 2, and then up through 5 again. So I guess this was a -4. I think I said 5, but -4 to 1 to 2 to 5. So that looks good. Problem is done.